Hello and welcome to week 8, lesson 1, where we're going to graph inequalities. And by the end of this lesson, I'm hoping that you'll be able to graph an inequality on a number line and correctly use an open circle or a closed circle to indicate the endpoint of the graph. And that'll all make sense here in a little bit. So like I said in the intro, inequalities are when the two sides of what we used to call an equation, or the two sides of the statement are not equal. All right, so because they're not equal, we can't use an equal sign. So the symbol is going to change. We actually have 4 different symbols that we're going to use. The first one looks like that. Looks like a lot of people will call it the alligator, right? That one right there stands for greater than. So an example of that would be 5 is greater than 2. That's how we would read that. 5 is greater than 2. Opposite of greater than is less than. Another example is 3 is less than 10. There's 2 more symbols that are very similar to what we just did. This one's greater than or equal to. And an example is 7 is greater than or equal to -4. And then less than or equal to. These are very similar to the first 2, but there's one additional thing put in there. And we're going to talk about how that plays in when we get to graphs here in a little bit. A solution of inequality is any number that makes the inequality statement true. Example 1, x is greater than 10. So we're looking for possible x values that make this true. Well, you're going to notice that there's a lot of answers, right? 11, 12, 13, 10.5, 10.4, 10.3. There's a lot of solutions, right? There's also a lot of not possible solutions. So numbers less than 10, so 9, 8, 7, and so on. So there are many solutions, not just one. So that's a little difference from equations. Equations we found most often had one number that made the two sides equal. Inequalities have many solutions most of the time. And so we have to graph those. So what we're going to do is we want to show all the possible solutions. So 11, 12, 13, all those numbers that we listed there, those are all to the right-hand side of 10. So we color that in. But then we have the question, what about the number 10 itself? We'll take a look at that with the next slide. Okay. Open or closed circle. That's how we show what happens at that number we're looking at. So in the last problem, it was 10. An open circle means that that number is not part of the solution, and a closed circle means that the number is included in the solution. So example 2, x is greater than 5. If I put 5 in for x, is that a true statement? Is 5 greater than 5? Well, no, it's not. It's the same. So it's not a part of the solutions. It's not a true statement. So we put an open circle. We do not want to include 5 as a possible solution. But all the numbers bigger than 5, we would want to show. So we would shade or color all the numbers bigger than 5. What about this one? X is less than or equal to 3. Well, 3, let's look at 3. Is 3 less than or equal to 3? Well, it's not less than, but it is equal to. And that's where that little underline piece right there means 3 is a solution. So we need to include it. How do we do that? By filling in the circle like you see here. All the numbers less than 3 are also solutions, like 2, 1, 0, -1. So we want to shade or color to the left. So example 3, we're going to look at freezing temperatures. So what temperatures are considered below freezing? Well, if you are aware of the numbers, 32 is kind of the number that makes that we separate freezing from non-freezing. So do we include 32 as a temperature below freezing? No, we don't. That's why we have an open circle there. All the numbers below 32 are the freezing temperatures. And the way we would write that is x is less than 32. What does x stand for? Well, x is the actual temperature. So those are the temperatures that would be considered below freezing. Voting age in the United States. If you didn't know, it's 18. If you're 18 years old, you can vote. Well, if that 18 is included, we need to fill it in. And then anybody older than 18 can vote. So all the numbers above 18 would be colored in, including the number 18. So we would say x is greater than or equal to 18, where x stands for your age. All right. Identify solutions by evaluating a given number. So, is each number a solution to this inequality? Yes or no? So it's a yes or no question. You would want to show your work here. If you just say yes or no, there's no credit given because you're not really showing understanding. What we're doing, though, is we're taking 3, putting it in for x, and seeing, does it make a true statement or a false statement? So let's look. So 2 minus 5x, I'm rewriting my inequality. Put 3 in for x. 5 times 3 is 15, so 2 minus 15 is negative 13. Is that a true statement? Is negative 13 bigger than 13? No, it's not. It's false. So that means 3 is not a solution. Pause the video. Try B and C and see how you do. Okay, hopefully you paused it and you tried it. With negative 4, you find 2 minus 5x. 5 times negative 4 is negative 20. And then you have 2 minus negative 20, which is 2 plus 20. And you get 22 is greater than 13. That's true. Since it's true, that means negative 4 is a solution. Finally, we'll try 0. Put 0 in. 2 minus 0 gives me 2. Is 2 greater than 13? No, it is not. So it is not. 0 is not a solution. Okay. That concludes our first lesson of week 8.